in this first part, in the first hour, we're going to talk about this concept called persistence context. You will find this under many different names. First level cache, entity manager, the Hibernate session. The last two are interfaces. Of course, they have implementations. In Hibernate, you have the session IMPL, which implements these two interfaces. They are all the same thing. Behind the scenes, Hibernate works like, as you will see, like a state machine. And by changing the entity state, some DML statement could be generated, like insert, update, or delete. Now, those statements are not executed right away. Hibernate doesn't work like active record, where you have an insert or update or delete method. I'm telling about that in the context of using the entity manager in Spring Data JPA. Of course, Hibernate has something like that's very close to active record, which is the stateless session. That's not very popular, but it's there, and it allows you to use Hibernate in a very similar way with active record. But the entity manager, whenever you're using repositories in Spring Data JPA, you are using this first level cache. And basically, every time you're calling like JPA repository save, you're calling the save method, and you're passing an entity that was never persisted before. Behind the scenes, you will see persist is going to be called. And if you do that multiple times, inside that entity manager, internally in Hibernate, there will be an action queue that's going to queue those actions, and only when flush comes, those actions will be executed, and then you'll see the statement. It's like the entity manager is a right behind cache. That's exactly how it works. In reality, many caches work like that. Even the database works like that. You make changes, and just because you made the changes doesn't mean that they are immediately flushed to the disk. The database will do that asynchronously. Sometimes hard disks work like that. The CPU might work like that. You make changes to some registers. It's not like those changes are automatically pushed to the main memory. Sometimes they are only the changes are only made on the first level cache or second level cache inside the CPU, and you need some memory barrier to be flushed to get them into the main memory. So this is something that's been around for many years in many places, and for a very good reasons. It's because of performance. By doing things, by delaying when you're doing an action, and combining and having a dedicated part where you're executing those actions, it allows you to do some optimizations automatically during that flush, as you will see. Because now we are going to study this entity manager and how it works, but later we also have the part about batching. And that's possible because of this. Without having this part, we wouldn't have that automatic batching. So that's why I'm starting with this part. All right, so as I told you, JP works like a state machine. Now, there are several states in which an entity can be. An entity starts in the new state. That's when you created the entity for the first time on the heap by calling the constructor. You're populating some properties, but that object only exists on the heap. It has never been persisted. In order to persist it, you have to call the persist method on the entity manager. Normally, when you're using Spring Data JPA, you're calling save. And if Spring Data JPA figures out that that's a new entity, it's going to call persist. And at that point, the entity it's in the state of managed. It's not like the insert is executed right away. Sometimes it does if it has the identity generator. But if you're using sequence, for instance, there's no insert at that part. You need a flush. You need to flush the entity manager, which happens many times automatically, and only then you will see the insert. If the entity is in the state of managed and you call entity manager remove, it will be in the state of removed. And when flush comes, you will see the delete. If you close the entity manager, or You have a transactional context because you executed your context in a service which was transactional, and you call some repositories, and now you're returning from that service, you're returning an entity into the web layer. That entity that gets into the web layer, of course, unless you're using the open session view, which you shouldn't, if the entity manager, if the transactional context was closed, the entity manager was closed as well, and the entity is in the detached state. If you make further modifications on that entity, they are not going to be propagated to the database because the entity is detached. What you need to reattach it, and for that you can use merge, for instance. I'm going to explain how that merge works further, but that's basically how it works. This is the way in which JPA and Hibernate were designed to work. By changing the state of the entity, that's how a given DML statement can be generated. And it's important to understand this because although we're using a high-level abstraction, Spring Data JPA or Spring, which hides all that, when it comes to performance, you have to understand how the framework works, because only by understanding it, you will know what exactly you should do in order to get the most out of it.